Hello everyone. In the last video we have seen the usage of the open source speech to text models. We have seen the OpenAI Whisper models, right? In this video we will be talking about that how can we fine tune them. So let's say you are running it for some use cases and you feel it's not working well for some extent. For any extent you feel this open source models are not working, right? So you can fine tune them. So important is you need the data for fine tuning for any machine learning task for any models. If you want to fine tune, you need to have data, right? So we will see how we can get the data and how we can, using that data, how can we fine tune it. So in this video we will be talking about fine tuning Whisper for Indian accents, for Indian languages, right? Okay, so this is the code. I'll quickly go through it. So these are the imports. I will not be talking about them. Okay, so first we need to create our collator class. Okay, so the collator class is a helper class basically, which prepares data which needs to pass to model. Why do we need this custom collator class in this case? Is because by default collator does not accept audio as input. They accept text as input, but for speech to text our input is the audio and output is the text, right? So that is the reason we need the custom collator class, right? So to explain collator, think of a collator like a helper that prepares a mini batch of data that needs to be fed to the model during training. So you don't pass data to model one by one for training. You need to pass a batch, right? Now when you pass a batch, let's say you are passing 8 samples together, right? So it may be possible that each of the samples or some of the samples have different audio length and some of the samples have different transcription length, right? Because transcription is also going as input, right? Though for speech to text the data should have both the audio part and the transcription, and that's how model learns, right? So if we try to stack all of these together, the model will complain, or model will throw error because their shapes don't match, right? So to solve this problem, the collator comes to rescue. The collator solves this problem by padding all the audio features in the batch of same length. Okay, so what it does is, if it feels that this audio is of less size or this text is of less size, it makes all of them same size by adding some special token to the empty locations. Okay, so what we are doing is we are padding -100, and it's a general practice to pad with -100 as a token. Okay, and model ignores this while calculating loss. That is, while learning, model knows that -100 is a special token, I need to ignore it, right? And why do we use -100? Because in PyTorch, if we use cross entropy loss, and we can easily set ignore index -100, it will skip this position while computing the loss. Okay, padding, I'm assuming I've already told you. Padding means adding extra values using usually 0 or some special token -100 in this case to make all the inputs of same length. Okay, so I'll quickly explain this again with an example. It is with a different example. So let's say we have 3 books. One is English book is of 100 pages, one of math book is 120 pages, and Hindi book is 80 pages. Now if we want to stack them in the nice pile, but they all of different heights, we need all of them to be of same size. So what we need to do, we need to add blank pages to English book to 20 pages and Hindi book to 40 pages, so that each of them now are 120 pages. Okay, so that's it, the role of collator. Now moving ahead, now this is where data comes in. Okay, so I'll show you where you can get the data for Indian languages. So AI for Bharat, this is a Swar data set for released by AI for Bharat. Please go through the license if you want to use it for non-commercial. For currently it says CC BY, so I think you can use it for commercial purposes, but still when you are viewing that video, might be the license got changed, so please do check the license before using it. Okay, it contains the audios in 19 different languages, 19 different accents of Indians. So audio is in English language only, but it has the 19 types of different accents of Indian. Okay, and corresponding text or the transcription. Okay, so you can simply download this and use it. So what would be your directory structure is this code. In the parallel, you have this Sora dataset directory with the test folder and the metadata file. Metadata file is the file with all the transcription. Okay, so all the transcription. So these are my audio files and these are the transcription. Okay, and this file comes with this metadata file comes with the dataset. Okay, now we are reading this using pandas. We are using this and we have created a data frame, and we have now converted to the Hugging Face dataset type in this code, and we are casting the audio to load. Basically now we are loading the audio and we are fetching the transcription here. So it now this data set is prepared using, now we are calling this prepare function, and now this final data set is prepared. Here we have created a sample. So it says general practice 10% test size and 90% train size. Okay, and now we have passed all those together. We have loaded the processor. In the previous video I already told you what the processor's job is. Now we have loaded the model, and we have doing this pre-processing function. Okay, this is the collator that we have created above, and these are the training arguments. So this is the directory where our final models, final checkpoints will be stored, and this is our batch size. This is the gradient accumulation steps. So I'll explain you these things. So idle, the batch size here becomes 32, 8 into 4. So every 32 samples, basically 32 samples are passed to the model one by one, but they are not getting processed together. They are getting processed 8 by 8. So there are 4 cycles in which 8 samples are being processed, and then they are passed into model for optimization, which is the learning stage. This is the gradient accumulation. This is done, let's say I don't have that much GPU, so that I can, so basically if I am training with a 32 batch size, it will require more memory, much more GPU memory, as compared to if I am training with the sample size of 8 with a gradient accumulation of 4. So it keeps that gradient in memory till 4 steps, and as soon as 4 steps are done, it will pass, it will optimize the model. That is, it will pass all the learning to the models. Okay, and now I've passed everything to the trainer, the train data set, the evaluation data set, the tokenizer, the data collator, and I've started the training. And I'll quickly run it to show you this code is working. Now this has loaded the data. I'm loading the model and mapping the data set here. Now this is actually pre-processing all the data and calculating the features, doing all the thing. Basically it's converting the audio or the input in the way the model needs. Okay, this is done now. These are the parameters I have changed default, and you can tweak it. I mean, they are straightforward. Okay, and now my training is start. So I'll just keep it running for a minute. It will keep on running for some time, and it will save the checkpoint every 200 steps. So you need to keep on tracking the error rate, basically loss of error loss and validation loss, to get to know if your model is learning, overfitting, underfitting. Ideally it will keep, you should keep on running it till the time your error loss and validation loss both are decreasing. If one of them start to increase, that means now is the time you should stop that training, and you can use the final checkpoint. As you can see, now our training has started. I have run it for 2000 epochs. Okay, it has given me out of memory error because my GPU is full, so I am killing it for now. So this is the data. I have shown you the TSV file, metadata file. This is the sampled metadata file. It has 2 columns. One is the audio file name, where it's located with the relative part of this file. So if your file is located here, so this is my directory structure basically. This is the Python file, which is your code I've shown you. Then parallel to that, there is a Sora dataset directory. In that I have a test directory, and in that test directory I have this metadata file, which is this file I've shown you, and all the web files. Okay, so with relative to this whisper underscore fine tune file, this is the path of the audios and the transcription. So this is the two files, and which can be downloaded from the Hugging Face dataset I've shown you. Okay, so that's it for this. If you have any doubt or any query, you can please feel free to put in the comment. I would be happy to answer.